So use matrices and row operations to solve this 3 by 3 system. So for the first row we use 3, 7, -1, and 11. And the next one is going to be 1, 2, -1, and 3. In the bottom equation, 2, 4, -2, and 10. And when I was writing them down, I noticed that this is all even numbers, so I could simplify things if I just cut all of those in half for row number 3. So everything else stays the same. The first row, the second row, and then for the third row, cut all the numbers in half. So 1, 2, -1, and 10. And then I can use row operations to get these to cancel out. So I would get, I think I need to move over here. So if I multiply the bottom row by a -1 and add it to the second row, it'll cancel out most of the second row. So take -1 times row number 3 and add it onto row number 2. So that operation only changes row number 2. The top row will stay the same. The bottom row actually stays the same as well, but it's only the row you're adding on to that gets changed. So if you multiply this by -1 and add it, it cancels, gives us a 0. The same thing happens here, and the same thing happens here. And this is going to be a -10 added to a 3 is -7. And at this point, I can actually stop, because what I had is, or what I have now is, this says when you have 0 x's and 0 y's and 0 z's, that equals a -7. So this row right here is saying that 0 equals -7, which is not possible, which means this problem has no solution. If we were to graph this, that means that these two planes that cause this to happen, these two planes are parallel. So there's no place where they cross, there's no solution.